boys and girls, it's Miss Bissell. We are working on lesson 4-5 today. We are in our books. We're going to start on page 190. We're going to be using models to multiply a decimal and a decimal. All right. On page 190, we're going to take a look at our essential question that's going to guide us through this lesson. We want to make sure that we know how to model decimal multiplication. All right, we need to understand the models, and in conjunction with that, we're going to talk about just the standard algorithm. All right, the visual learning scenario has a carpenter who cut 2 shelves with the dimensions given below. We need to show how to use a model to find the area of each shelf. And then the question is, will each answer be greater or less than 1? So our first shelf is 3/10 of a meter by 5/10 of a meter. Our second shelf is 5/10 of a meter by 1 5/10 meters. All right, so let's deal with the shorter shelf first. All right, so for the shorter shelf, we're going to shade the first 5 columns and the first 3 rows of the hundredths grid. So here we go. This in purple represents 3/10 or 30 of these hundredths. Those are equivalent, right? And then to go the opposite direction, that we're going to do 5 columns for 5/10, or you could look at it as 50 of the individual hundredths. All right. What is in the crisscross area that overlaps is the product. Okay. So the area of the shelf is the brown area where the shading overlaps. Okay. You can write this area as the product of the decimal. So the area of the shorter shelf then is 1,500 square meters. All right, I want you to take a look at this. And let's go back to what we learned the last couple lessons. If we were to ignore the decimals and just multiply these as whole numbers, we get 15. 3 times 5 is 15, correct? All right, but now we need to contend with the fact that they are decimals. So if you remember from our last few lessons, we count the number of decimal places in our factors. So we have 1 decimal place in the first factor, another decimal place in the second factor. So we have a combined number of decimal places as 2. So we need to have 2 decimal places in our answer. So now we firm up this answer. 1,500 is what we have here. Since there's no whole number, you guys know that we put a 0 there. And we just checked our model with the standard algorithm. All right, for the longer shelf, we are going to have to use 200ths grids side by side. And the reason we have to use 2 is that one of its dimensions has 1 whole and 5/10 of another meter. So that means we have to use 2 decimal grids, okay? 1 whole decimal grid, and then we're going to be shading then 5/10 or half of the next decimal grid. So let's look how it works. All right, they're telling us we're going to shade 15 columns to represent the 1 5/10 meters, and we're going to shade 5 rows to represent the 5/10 of a meter. So in purple, we are shading our 5 rows. We have to go all the way across because it's 5/10 of both the whole number and the decimal part of 1 5/10. And then our columns, we're shading in green to represent 1 whole and 5/10 of the next decimal grid. All right, where we have overlap, which makes this kind of ugly brown color, is where our product is. So if you count the area, you have 75 of the little individual hundredths. So our product of the longer shelf is 75 hundredths of a square meter. Now let's check it traditionally. Again, we're just going to pretend that these are whole numbers. You guys shouldn't be able to count by 15 5 times. 5 times 15 is 75. All right, now we don't really have whole numbers, so let's contend with the decimals. We have 1 decimal digit place in the first factor, 1 in the second, for a total of 2 decimal places. So we need 2 decimal places in our product. 75 hundredths needs a 0 at the front of it to hold or to show that there's no whole number. All right, so we just checked the model with the standard algorithm. All right, let's talk about what you need. You probably need to pause the video, and if you have it, you need 2 colored pencils, 2 different colors. I'm going to just use my yellow and blue. All right, so we're going to work through the guided practice. All right, we're on page 191. All right, we're just going to move straight to 3 and 4. We're going to shade the hundredths grids to find the product. So number 3 is very much like the smaller shelf. All right, each dimension is less than a whole. So we have 7 tenths times 8 tenths. So I'm going to use my yellow, and I'm going to do 7 of my tenths. So I'm going to shade down all but 3 rows. Let me get some light on here. I'm having a hard time seeing. All right, now I should be able to stay in the lines. So this whole area right here represents the first factor, 7 tenths. Got 7 rows. All right, now 8 tenths, I need to shade 8 of the columns, 8 tenths. So I'm going to go all the way across. I'm going to go 8 across. Take me to there. Okay. So the area then where my 7 rows and my 8 columns cross is where my product is going to be. So when I look at it, I have 1, 2, 3, 4, 5, 6, 7, 8 in each row that are double shaded, and I have 7 rows of that. So I should get 56 hundredths shaded. All right, now let's check that with the standard algorithm. So we're just pretending these are whole numbers. So that's true that 7 times 8 is 56. All right, we have 1 decimal place in this factor, 1 decimal place in the other factor. So I'm going to put in 2 decimal places in my product. I need a 0 for my whole number, and I just checked my answer with the standard algorithm. All right. Number 4 is going to be very much like finding the area of the larger shelf. All right. One of our factors is less than 1 whole, and the other one is actually 2 wholes and a little bit of a third. So I'm going to use my yellow to shade my one row, 1 tenth. So we're going to come all the way across. All right. And I have shaded 1 row. Now, to shade 2 1 tenths, that means I need to shade 2 holes. So both of these decimal grids will be shaded to represent 2 holes being shaded. All right, and then we need to shade 1 tenth of the third decimal grid, which would be this one right here. All right, now the area that is the product is where the yellow and the blue overlap. So I have 10 tenths here, 10 tenths here, and 1 here. So hundredths. I have 10 hundredths, another 10 hundredths, and 1 hundredths. So what I have are 21 hundredths that are shaded. That is my product, okay? Now, let's check it with the standard algorithm. As whole numbers, 1 times 21 would be 21. I have 1 decimal place in this factor, 1 in the other factor, so I need 2 decimal places, the whole number 0, and that confirms that my model is correct. And if you think about it, you can go back to one of our lessons that we did. I believe it was lesson 8.8, and we talked about multiplication and scaling. And since we are multiplying a number smaller than 1 times another number smaller than 1, then what happens is our answer is going to be less than each of the factors, right? If we were multiplying a number by 1, it would equal itself. If we had the second factor was greater than 1, then the product would be greater than the factor with the 1. But that's not the case. We're getting smaller parts when we multiply decimals. All right, let's take a look at 5 through 8. You boys and girls can work these out on your own and then come back and I will talk about them, okay? Or you can work through them with me. The choice is yours. Just hit the pause button and work at your own pace. All right, number 5, we are shading 4/10 and 5/10. So we need to shade 4 rows. Okay, to represent the first factor. All right, and we need to shade 5 columns to represent the second factor. All right, remember the product is going to be in the overlap region, okay? So kind of this area that kind of takes on a tingy green color. So I have 1, 2, 3, 4, 5, 10, 15, 20 hundredths that I see are shaded. And we write 20 hundredths as this, or we can actually write it as its equivalent decimal 2/10 by getting rid of that unnecessary 0. All right, let's check it with the standard algorithm. As whole numbers, 4 times 5 would be 20. We have 2 digits, decimal digits in our 2 factors, so we need 2 decimal digits in our answer, and we need a 0 to show that there is no whole number. Now, once we have placed the decimal, then we can get rid of that 1 0 that we don't need and write the equivalent decimal, and that confirms our model is correct. All right, number 6, 3/10 times 7/10. So I need to shade 3 rows to represent 3/10, the first factor. All right, I need to shade 7 columns to represent the second factor. All right, the answer lies in this overlap area that for us is tinged a little bit green. So I have 7, 7, and 7. So I have 21 of those hundredths shaded. Let's check it with the standard algorithm. As whole numbers, 3 times 7 is 21. We have 2 digits behind the decimal places in our factors, so we need a total of 2 digits in our product. We have 21 hundredths. We know that our model is correct. All right. Let's take a look at number 7. Number 7 and 8 look very much like finding the area of that larger shelf, okay, in our example on the visual learning. All right, first thing we need to do is we need to shade 5 rows to represent 5/10. And don't forget, we have to shade it in both of our models. I just broke my crayon. So you know what? I'm going to switch over, or my colored pencil. I'm going to switch over to a highlighter, and I'm going to do 1 row. That one, of course, is not working very well. Let me get another one. All right, here we go. So we're going to do 1 row, 2 rows, 3, 4, 5. Okay. Now, for the columns, we need to shade 1 whole and 7/10. All right, so we're going to do all right, this whole one, and then 1, 2, 3, 4, 5, 6, 7. All right, and the shaded area is where we have the green. All right, so I have 17 hundredths, and I have 5 rows of 17. So really in this area, I have 85 hundredths that are shaded. Okay, now let's check our work. 5 tenths times 1 and 7 tenths as whole numbers. 5 times 17 is 85. I have a decimal digit here and another decimal digit here, so a total of 2 decimal digits. So I get 85 hundredths. I know my answer is correct. All right, let's look at the last one. 6 tenths times 1 and 2 tenths. So I need to shade 6 rows. So it needs to go across 2, 4. Nice. If I turn my pen that way, I can get them all. And then I need to do 1 complete model and 2 columns of the next. All right. And the shading that's turning green here is going to be where my product is. So I have 12. I have 6 rows of 12. So that gives me 72 of the little hundredths shaded. And then if I want to check it with the standard algorithm as whole numbers, 6 times 12 is 72. I have 1 digit in this factor behind the decimal place and 1 digit in the second factor behind the decimal place. So that means I need a total of 2 decimal digits in my product. So 72 hundredths confirms my model. All right, at this point, I am going to come away from the models, okay? I'm going to treat these as whole numbers, okay? So here we go. I know that 2 times 8 is 16, right? And I have 1 decimal digit in this factor and 1 in this factor. So I need 2 decimal digits in my answer. So I get 16 hundredths. All right. 2 and 4 tenths times 7 tenths. 2 and 4 tenths would be 24 times 7 if I treat these as whole numbers. Get 168. So now I need to look at where my decimal is going to go. I have 1 digit behind each factor, or in each factor, 1 decimal digit. So I need 2 in my answer. So I get 1 and 68 hundredths. Number 11, 3 and 9 tenths times 4 tenths. I'm going to multiply those whole numbers, 39 times 4. I get 156. And then I have to determine where my decimal is going to go because I'm not really multiplying 39 times 4. I'm multiplying 3 and 9 tenths times 4 tenths. I have 1 decimal digit place here and 1 here for a total of 2. That means I need 2 decimal places in my product for 1 and 56 hundredths. All right. Next one, I'm going to treat this as 5 times 7, 5 tenths times 7 tenths. So 5 times 7 is 35. I have 1 decimal digit in each factor for a total of 2. So I get the answer 35 hundredths. All right. This one right here should be pretty easy. 1 times 9 is how I'm going to treat this problem. 9. Then I'm going to deal with the fact that I need 2 decimal place values. So I'm going to have to put a 0 in front of the 9 and the decimal here. If I put the 0 behind the 9 and the decimal, then I would have totally changed the value of that number and I wouldn't have had 9 hundredths. I would have had 90 hundredths or 9 tenths. So I've got to be careful with that. And there's a 0 that's going to go right there. All right. 2 times 15 is how I'm going to treat multiplying 2 tenths times 1 and 5 tenths. 2 times 15 is 30. All right, I have 2 decimal digits in my 2 factors, so I need 2 in my answer. So I get 30 hundredths. Don't forget, we don't need that extra 0 behind any digits behind a decimal number. We're going to write the equivalent decimal, 3 tenths. All right, 6 tenths times 6 tenths. We're going to start by treating it as 6 times 6 is 36. We have 2 decimal digits in the factors. I need 2 in my answer. So we get 36 hundredths. All right. And the last one, 28 times 3 is how I'm going to multiply 2 and 8 tenths times 3 tenths. So 28 times 3 gives me 84. All right, I take a look. I've got one decimal digit in this factor, a second decimal digit in this factor. So that means I need two decimal digits, decimal place value digits in my product. So I get the answer 84 hundredths. All right, boys and girls. So we worked with multiplying a decimal by a decimal with models today. And then we confirmed our answer just practicing the standard algorithm where we count the decimal places in our two factors and we place that decimal in the product using compensation. We talked about that the last two lessons, okay? All right, ladies and gentlemen, you're going to be working on your individual assignment, and I will see you for our next lesson in decimal multiplication tomorrow.